In this video, we'll generate the Euler's cosine using IMEXP IMREAL complex factorial and the Taylor series using SERIESSUM. We begin with the values of f, the frequency, which is data validation, list of items, that's from 0.4 to 1.5. We can start with 0.5 and we continue. We have the SERIESSUM, the expansion, which is the summation of a times x to the power n, where the value of n is from 0 to infinity. 20 is good enough, and the value of a is equal to array formula, cosine n times pi times f, so n times pi times f divided by factorial n. Enter. Now we can complete the expansion. So array formula, series of the x values raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range. And we continue with the Euler's cosine, which is the real part, of the Euler's number raised to the power a cosine number, where the complex numbers are x times cosine pi f plus I x sine pi f. We begin with the complex number. So array formula, complex, that's x times cosine pi f. So x times cosine pi times f. That's the first part. The second part is, this is I, so we have a comma. So x sine pi f. So x times sine pi times f, and close the parenthesis, and close the parenthesis, and enter. Now that we have the the complex number, this is Euler's number raised to the power this number. So this will be IMEXP of the complex number. So IMEXP, Euler's number raised to the power the complex number. And finally, this is the real part, only the real part. So we take out the real part, IMREAL, the real coefficient of the complex number. And we'll chart this. Insert chart. And we use scatter chart. Column is label. And we show the trend line. Under series, the trend line, the type polynomial, the degree, we try 8. For the label, or we'll try 6. For the label, use the equation. And we can delete this, we don't need a title. So here's our trend line and polynomial. Now we can start from 0.4. So f is equals 0.4, we also assign 0.4. Now they're the same. At f equals 0.5, You also use 0.5. Now we have a cosine function. You change this to 0.6, which also changes to 0.6. Now they're the same. It's a decaying cosine function. Change this to 1.45. We also change this to 1.45. A decaying cosine function. Change this to 1.5. We also change this to 1.5. Now it's a steady state cosine function. Change it to 1.5. And it's 1.55. An expanding cosine function. So this completes the use of the functions IMEXP, IMREAL, complex factorial, and series sum to generate the Euler's cosine and its Taylor series expansion.